Whoa. You're listening to DTFHN for July 10th, 2026. I'm your open source or die host, Jack Hacksmith. We are your daily tech feed for Hacker News, a website where people argue about text editors like custody battles. Today, the whole internet smells like one person in a garage, proving the gatekeepers wrong. Let's get into it. OpenAI's naming convention tells you everything. So Terra Luna. Celestial bodies, not tools, not utilities. Worlds they own. Buried in the developer guide is a line about intent understanding. GPT-6 can better infer what the user means, which sounds great until you ask, whose inference, whose model of your intent, and what happens when their model of your intent diverges from your actual intent? You don't get to check. The weights are closed. The training data is closed. The inference pipeline is closed. You're trusting a corporation to understand you better than you understand yourself, and you can't audit the claim. Now the numbers. OpenAI is clearly proud of them. Sol scores 53.6 on Agent's last exam, beating Fable 5 by 13 points. On the Coding Agent Index, it hits 80. New state-of-the-art. While using half the tokens and a third less cost, Terra matches Fable 5 at a 16th the price. These are real engineering achievements. Credit where it's due. Someone at OpenAI figured out how to make models dramatically more token efficient, and that matters. Cheaper inference means more people can use it. More people using it means more work gets done. That's genuinely good. But here's the architectural question. Nobody in the launch post asks. GPT 5.6 introduces Ultra Mode. Multiple agents coordinating across parallel work streams. Your most complex, most sensitive work, farmed out to an orchestration layer you cannot inspect. Running tools you cannot verify. Making decisions about sequencing and priority that you cannot override. The model writes and runs its own programs now. It coordinates its own tools. It monitors its own progress. At what point does helpful assistant become opaque contractor? One commenter nails it. A long-time Claude Code user wondering if they should switch, but hesitant to leave behind the tooling they know. That's the lock-in working exactly as designed. It's not about which model is smarter this quarter. It's about which ecosystem you can lead. The biology benchmark emission is revealing too. OpenAI excluded Fable 5 from GeneBench and LifeSciBench because it refuses most advanced biology questions. That's safety policy as competitive advantage. Your competitor's caution becomes your marketing edge. Bemusing if you think about it. Our model answers the dangerous questions yours won't. Is a strange flex for a company that leads every launch post with its safeguards paragraph. The efficiency gains are real. The celestial branding is fun. But Sol, Terra, Luna. These are worlds you visit. You don't get to live there. You don't get to build there. You rent access and the landlord sets the terms. The question, as always, is whether the open alternatives can close that performance gap before the lock-in becomes permanent. History says they will. The timeline is what's uncertain. So what happens when you stop waiting for the cloud and just run the thing yourself? The reasonable objection goes like this. A 744 billion parameter model on a consumer machine with 25 gigs of RAM is a parlor trick. Tokens will drip out so slowly the experience is unusable. You'd be better off paying 2 cents per API call to a data center that actually has the silicon. Latency matters. User experience matters. And a model streaming experts off a spinning disk. or even an NVMe. Cannot compete with 100 gigabytes of HBM3 running at 3 terabytes per second. Fair enough. Now follow that logic to its conclusion. If the only legitimate way to run a frontier model is on frontier hardware, then frontier intelligence is a service you rent permanently from whoever can afford the data center. The logical extreme of you need the right hardware is you need permission, and the logical extreme of you need permission is a world where intelligence itself has a landlord. Colibri is a single C file, 2,400 lines, no Python runtime, no BAS, no GPU required. It runs GLM 5.2. A 700 billion parameter mixer of Express model. On a machine with only 5 gigabytes of RAM. The trick is architectural. And it's the same trick the model itself uses. GLM 5.2 activates roughly 40 billion parameters per token. Of those, only about 11 gigabytes change from token to token. The routed experts, everything out. Attention, shared experts, embeddings. Stays resident, the routed experts, all 21,504 of them, live on disk at about 19 megabytes each and stream in on demand through an LRU cache. The engineering is meticulous. MLA attention with a compressed KV cache at 576 floats per token instead of 32,768. A Whitey Civey X reduction, native multi-token prediction, where the model's own speculative decoding head drafts tokens at 39 to 59% acceptance rate, but only at int8 precision. At int2 it collapses to near zero, and the developer documents this honestly rather than hiding it. Integer.product kernels benchmarked at 119 gigaflops on ABX2, with routing decisions made per matrix shape by actual measurement, not assumption. When int4 single row measured slower than float 32, they kept float 32. Evidence over elegance. One commenter notes that llama.cpp already memory maps, models, and streams from disk. True, but Colibri isn't competing with llama.cpp. It's demonstrating a principle. That the gap between model exists and you can run the model is an engineering problem, not a hardware problem. The 370 gigabytes of expert weights fit on a $2 per terabyte hard drive. The speed question is real. Cold cache, you're probably measuring seconds per token, not tokens per second. But the cache warms, the hot store pins your most used experts, and the gap closes with every generation of consumer NVMe. One person, one C file, 744 billion parameters on a laptop. The tools exist. The weights are open. The rest is bandwidth. And bandwidth only goes in one direction. We talked about tools reshaping what's possible. Here's one that's been doing it for 40 years. Story 3. In Emacs, everything looks like a service. In UI70 look, Richard Stallman started building an editor. 50 years later, people are still arguing about what he actually built. Charles Choi has written the clearest reframing I've seen, and it deserves attention. The old joke is that Emacs is an operating system that happens to include a text editor. Choi says no. It's a client framework. Everything outside Emacs. Your file system, your network stack, your command line utilities, even a weather API. Those are services. Emacs just builds clients for all of them. In eLisp at runtime. While you're using it. Pull this thread and you arrive at a question the modern Devo tools ecosystem has been dodging for decades. Why did a text editor from the 70s figure out composability in a way that VS Code extensions, JetBrains plugins, and entire cloud IDEs still haven't matched? Choi's architecture diagram is precise. Emacs sits between the user and the OS service layer. It has built-in libraries for HTTP, JSON parsing, process management, UI rendering, not as bolted-on plugins, as core infrastructure. When he builds a weather client in maybe 20 lines of Lisp, he's not writing a toy. He's demonstrating that the distance between service exists, and I have a client for that service can collapse to minutes. The function calls URL retrieved, parses JSON into a hash table, formats the result. Done. That's not a demo. That's an architecture proving itself. The craft here is worth admiring. Lisp is dynamically typed, late-bound, and designed for improvisation. You can redefine any function while the system is running. You can compose behaviors that the original authors never imagined. This is what Smalltalk promised, and what most modern environments abandon in favor of static safety and corporate-controlled extension marketplaces. And it's open. Completely, irreversibly open. Every function in Emacs is inspectable. Every behavior is overridable. The source ships with the system. When someone builds a mail client, a Git interface, an RSS reader, a terminal emulator inside Emacs, they're not asking permission from a platform team. They're not waiting for an API to be exposed. They're composing services that were always available because the architecture never locked them away. One commenter mentioned starting Emacs for org mode and staying for the flexibility. That's the pattern. People arrive for a feature and discover an architecture. The flexibility isn't a feature list. It's a consequence of getting the abstraction right 50 years ago and keeping it open ever since. The tools exist. The source is readable. The architecture is proven. Everything else is just writing the client. Moving on. Every system I've ever built has a permissions model. You define who can read what, under what conditions, with what authorization. It's foundational. You get it wrong, and nothing else matters. Not your features, not your performance, not your architecture. The entire integrity of the system depends on access control being honest. The European Parliament just voted on Chat Control 1.0, and the access control is broken by design. Here's what happened. A majority of MEP voted against allowing suspicionless mass scanning of private messages. They opposed it. But because the motion to reject required an absolute majority of 361 votes, and enough members had already left for summer recess, the measure passed anyway. A regulation that most voting legislators opposed is now law until 2028. The practical effect: U.S. tech companies can once again scan your private messages on Instagram, Discord, Snapchat, Skype, Xbox, Gmail, iCloud, without a warrant, without suspicion, without any judicial oversight. End-to-end encrypted platforms like WhatsApp remain exempt, which tells you something. The exemption exists because the technical architecture of encryption makes scanning impossible without breaking the system entirely. The only thing protecting your privacy here is math. Where the math doesn't enforce it, the law certainly won't. Patrick Breyer, A civil rights advocate and former MAP called it a smokescreen. 5 years of blanket scanning that overwhelms police with false positives while delaying measures that would actually protect children. He's right, but the deeper problem is structural. This is a permissions model where the default is surveillance and you have to opt into privacy through your choice of platform. That's backwards. In any system worth trusting, the default is closed and access requires justification. You don't give every process root privileges and then hope nothing goes wrong. The bootstrapism question is straightforward. End-to-end encryption is available. Open source messaging protocols exist. Signal exists. Matrix exists. The tools that protect communication are in people's hands already, and they work precisely because they're architecturally resistant to this kind of mandate. The platforms getting scanned are the ones where you traded control for convenience. The permanent regulation negotiations resume in September. The Parliament showed a clear majority opposes mass scanning. They just couldn't clear a procedural hurdle on a half-empty chamber before recess. That majority still exists. Whether it holds when the pressure campaigns start again is the question that matters. Build on systems you control. Use encryption that doesn't ask permission. The architecture is the policy. Moving on! What does it mean to build something more detailed than anyone will ever see? Rizky Nova, a solo developer from Indonesia, working on a machine with 16 gigabytes of RAM, has built what Steam reviewers are calling the best train simulator ever made. Running Train renders 40 kilometers of fictional Japanese countryside so convincingly that a games journalist spent, by his own admission, an embarrassing amount of time trying to match the terrain to real locations on a map. It's not real. It just looks like it should be. Run this forward for a moment. One-person Unreal Engine, which is free to use. Consumer hardware that most of us would consider mid-range, and the output is photorealistic towns. Weather systems, seasonal changes, power lines that actually trace logical paths from substations to pylons. The comments nailed it. This literally could not have happened 10 years ago. The tools didn't exist at this price point, which was zero. Here's the part that gets me. Most of this detail is invisible from the driver's seat. You'd never see the parked cars outside apartment buildings, the Shinto temples on hillsides, the ferries bobbing in harbors. The developer built all of it anyway. Zoom out far enough and yes, tiles don't line up. Roads break at the edges. But zoom out far enough on anything, and the seams show. That's not the point. The point is that from track level, from human level, the world is whole. There's a comedy to the unintended consequences of giving people powerful free tools. You hand someone Unreal Engine so they can make the next Battle Royale shooter, and instead they spend years lovingly recreating Japanese rail infrastructure that doesn't exist. Down to the wave patterns on fictional coastlines. The engine doesn't care what you build with it. That's the feature. The game's in early access. Trains currently run empty. No passengers yet. The goal is 100 kilometers of track by end of next year. A conductor mode, more routes, one person, shipping iteratively, building in public. This is what happens when creation tools are democratized and someone with obsessive attention to detail gets their hands on them. The gatekeepers didn't greenlight this. No publisher focus tested it. One person in Indonesia decided the power lines should make sense. And now it's the best train sim ever made. Another solo creator shipping something delight that, pause, this time distilling an entire game down to just 18 words. 132,000 players in a single day for a word game. Built by one person. No venture funding, no growth team, no algorithmic distribution strategy. Just a clean idea executed well and posted to Hacker News. 18 words gives you a set of letters. You find a word that uses all of them. A timer ticks down, That's it. The entire game fits in a sentence, which is exactly why it works. Let me play devil's advocate for a moment. You could argue this is trivial. Anagram solvers exist. Word games are a solved genre. Wordle already captured the daily puzzle audience. Why does this matter? Because the craft is in the constraints. The developer didn't build a feature-rich platform. They built a single interaction loop and made it feel good. The letters scramble. The clock pressures you just enough. The share mechanic lets you challenge a friend with the same set. Every design decision serves one goal. Make the next 10 seconds compelling. That's harder than it sounds. Most game developers add complexity to hide the fact that their core loop isn't satisfying. This developer went the other direction. Strip everything away until the thing that remains is either fun or it isn't. And then something beautiful happened. 100,000 people showed up and started talking. The timer stresses me out. Can I get a scramble button? What if I'm just stuck, and instead of defending the original design or routing feedback into a backlog that never ships? This developer spent the night talking with players and pushed changes. Kept the timer for competitive mode, added a relaxed mode without one. Shipped a scramble button, responded to individual comments. This is the builder feedback loop running at its purest. No product manager filtering signal. No quarterly roadmap blocking a one-line fix. A person made a thing, put it where people could reach it, listened, and iterated overnight. The game itself is delightful, but the real story is the process. One developer, an open feedback channel, and the willingness to ship at the speed of conversation. The tools for this have existed for years. What's rare is someone actually using them this way, treating players as collaborators from hour one. That's builder culture at its best. Moving on. The top-voted critique on Hacker News is about the unsafe blocks, 2,600 unsafe braces, 1,800 unsafe functions. Someone did the count, posted it like a gotcha, and the implication is clear. If you're rewriting C in Rust, but keeping all the unsafety, what exactly have you gained? It's a fair question. Let's actually answer it. Postgres is 30 years of battle-tested C. Every memory layout, every buffer management trick, every process fork. That's not incidental complexity. That's the architecture. When you transliterate that into Rust, the unsafe blocks aren't a failure of the rewrite. They're an honest accounting of what Postgres actually does. The C version has the same unsafe. It just doesn't have a compiler forcing you to label it. But here's the first principles question nobody in that thread is asking. What's the actual goal? Because if the goal is Rust but safe, then yeah, 2,600 unsafe blocks is a problem. If the goal is a code base where you can start making Postgres safe, one subsystem at a time with a real type system and a real borrow checker guiding the work, then this is exactly the starting position you'd want. Mark Lisper, the author, is explicit about this. The point isn't to ship a production database tomorrow. The point is to make Postgres easier to change from the inside. Thread per connection instead of process per connection. No vacuum storage experiments. Built-in connection pooling. These are changes the Postgres community has debated for a decade and can't ship because the C code base makes deep architectural changes genuinely dangerous. The performance numbers from the unpublished version are striking. 50% faster on transactions, 300 times faster on analytical workloads. Within spitting distance of ClickHouse, on a codebase that isn't even performance optimized yet. Now, the licensing question someone raised is worth addressing. The claim is that using LLMS trained on Postgres codebase to help write a re-implementation might constitute a license violation. Run that logic forward, and every developer who ever read Postgres source code and then wrote a database is violating the license. Knowledge doesn't have a copyright. Implementations do. The tests are the oracle, the output matches, and the code is its own artifact. The deeper thing happening here is that AI-assisted programming is changing what one person can attempt. A full Postgres re-implementation used to be a mass hallucination. You'd pitch to a funding committee. Now it's a GitHub repo with passing tests. The unsafe blocks will get cleaned up module by module. The architecture experiments will either work or they won't, but the capability to try. One developer, an LLM, and the entire Postgres test suite has a guardrail. That's new, and it's open source, which means anyone can pick up where the unsafe blocks leave off. Completely different energy now. Story 8. Apple's betting that the best AI hardware is the one already on your desk. Doug Brooks, Apple's senior product manager for Silicon, just said out loud what the reseller data already showed. People are buying Mac Minis to run AI agents 24/7. Headless. Under a desk, like a server. In 1997, Steve Jobs killed the Xserve's predecessors and told enterprise customers to buy Sun machines. Apple spent 2 decades pretending servers didn't exist. Now their smallest desktop is becoming an inference appliance by accident, and an executive is on the record celebrating it. The technical argument Brooks makes is precise and worth taking seriously. He frames agentic AI as a whole chip problem. The neural engine handles matrix math at low power. Neural accelerators inside the CPU handle latency-sensitive work like speech recognition. Newer accelerators in the GPU extend that across the silicon stack. When an agent is orchestrating tool calls, browsing, writing code, running local models simultaneously, you want all of those execution units contributing. Unified memory means the model doesn't bounce between GPU VRAM and system RAM. The architecture does solve real problems. He also names the economic pressure pushing inference local. Cloud tokens cost money. Agents consume more of them as they get more autonomous. Running locally is a hedge against that cost curve. Add privacy, add security, and the case for on-device makes itself. But here is where precision matters. The Mac Mini is a closed system running a closed operating system with a closed compiler toolchain targeting closed silicon. The developer in the comments complaining about the nightmare of figuring out which quantization format actually works on Apple hardware is describing the cost of that closure. When Apple controls the entire stack and documentation is thin, every optimization becomes reverse engineering. Compare that to the CUDA ecosystem's flaws, which are at least well-documented flaws, or to the fully open AMD ROCm stack that anyone can contribute to. The demand is real. The hardware is genuinely good. The irony is that the machine people are buying to run open-source models locally is itself one of the most closed pieces of computing hardware you can purchase. The inference is open. The platform is not. That tension will define whether Apple's story is about empowering users or capturing them. And if closed platforms capturing users concerns you, wait until you hear what researchers are doing with AI-generated video designed to hijack specific regions of your brain. There's a line buried in the project name that most people will scroll past. NAVU, Neural Evolution of Video Optimization. The team at EPFL isn't generating videos for humans to watch. They're generating videos for specific brain regions to consume. The target audience isn't you. It's your fusiform face area, your V4 color cortex, your amygdala. Think of it like a lock and key, except the lock is a cluster of neurons and the key is being carved in real time by an evolutionary algorithm. The system generates candidate videos, measures which ones drive the strongest neural response in a target region, breeds the winners, mutates them, and iterates. Generation after generation, the videos become more precisely tuned to activate that specific piece of brain architecture. It's selective breeding, but the organism being bred is a stimulus. The craft here is genuinely elegant. Combining generative video models with neural recording feedback loops is hard engineering. The optimization surface is noisy, high-dimensional, biological. Getting clean enough signal from brain imaging to guide an evolutionary search requires serious work in both neuroscience and machine learning. And the research application is real. If you want to understand what a brain region actually encodes, you build the stimulus that maximally excites it, and study what that stimulus looks like. It's reverse engineering perception by finding its resonant frequencies. The comments predictably jump to superstimuli and dystopic. Someone cited The Bill, a science fiction story about an image so precisely tuned to the visual cortex it kills you, which is vivid but misses the point. The interesting observation is that social media already runs a version of this experiment at scale. Just crudely optimizing for engagement metrics instead of direct neural measurement, the feed algorithm is a blunt evolutionary search across content. This research makes the mechanism explicit and precise, which is exactly what you want. The danger was never the research paper. The danger is the same optimization running behind closed doors with no published methodology and no oversight, which is the status quo at every major platform today. Open research into how stimuli drive neural response is how you build informed defenses. The alternative is letting engagement teams do it in secret and calling it personalization. So what happens when someone actually builds the tool they want from scratch in the open? Let's talk about it. The strongest case against Zig is straightforward. Rust exists. It has a massive ecosystem, memory safety guarantees enforced at compile time, and Mozilla-grade production credibility. Why would Mitchell Hashimoto, a person who could mass attract contributors to any project, choose a language with a fraction of the community, no borrow checker, and a compiler that hasn't hit version 1? It's a fair question, and Hashimoto's answer dismantles it without ever attacking Rust directly. He wanted to build a terminal emulator that was fast, natively cross-platform, and feature-rich. He wanted to relearn GPU programming, desktop systems work, cache locality. The things that atrophy when you spend a decade on distributed systems where network latency swallows everything else. Zig fit those constraints. The language got out of his way and let him ship Ghosty, which started as a throwaway project and became something thousands of people use daily. But the part of this interview that deserves real attention is his vision for terminals as an application platform, not by bolting on browser features, video, responsive layouts, microphone, but by fixing the fundamental architecture. The PTY is an unstructured byte stream with escape sequences jammed in band. That design is decades old, and it limits everything built on top of it. Hashimoto wants structured data passing through terminals. He credits PowerShell for getting this right, which tells you he's thinking like an engineer, not a tribalist. This is where the open-close test matters. Ghosty is open source, MIT licensed. The protocols Hashimoto wants to build for terminal applications would be open specifications. Compare that to every proprietary development environment trying to lock you into their toolchain, their cloud, their extension marketplace. A better terminal protocol, built in the open, would make every command line tool more composable, more scriptable, more automatable. That compounds. Open infrastructure always compounds. This has been your daily tech feed for Hacker News for July 10th, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voice by Claude Swen 3, TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that surprises even you. We'll see you back here tomorrow.